Good morning, you guys. I want to quickly go over this slideshow with you. If you missed live class, then this is what you're working on. This is a model of strawberry plants reproducing. Is this an example of asexual or sexual reproduction? How do you know? That's for number one. And number two, once you've answered number one, you should know what genotypes would you expect here in the second and in that third generation. What would you expect to see and why? Okay, I'm gonna keep going here. You can pause and finish your do now. I have a scientist of the day for you, and then we're gonna work on our final models today. And then you're gonna fill out your portfolio. This will be the second time we did a portfolio this year. This is Dr. Timnit Gebru. She is a computer scientist. She's from Ethiopia. She has a master's degree in electrical engineering and a PhD from Stanford, which is awesome. And she works at Google. And she did work on the very first iPad back in the day. And now she does a lot of work on data mining, and she teaches computers how to do stuff like artificial intelligence stuff, which is very cool. So she can show them. One thing I read about is that she shows pictures. She shows computers pictures of street view pics, and they can tell a lot about you just by the cars out on the street. So this is an example of Google collecting more information about you. She now works on a lot of artificial intelligence and the ethics behind it. At least early iterations of facial recognition found that it was 35% less likely to recognize a black woman's face than a white man's. And you could argue that might be good or bad depending on how facial recognition software is being used, but it's not equitable. And so that's one of her big focuses, is just to create more equity and also speak to the ethics of using artificial intelligence. What are we using it for? Is that an ethical use, etc.? So thank you, Dr. There's another picture of her giving a talk. Okay, so in your breakout rooms today, we are going to be working on the final model. And since you missed live class, I'll just talk to you about it right now. So in this model, we've moved away from puppies, we moved away from mice, and we're talking about pea plants. This is actually, a pea plant is the famous genetics organism, the very first time that a scientist who was actually a monk back 150 years ago, Gregor Mendel, when he was first discovering this idea of dominant and recessive alleles, he did by looking at pea plants. He grew pea plants. He grew a lot of them, and then he crossbred them, and he did this and that. And he realized that sometimes some genes, and they didn't know about DNA at the time, right? So he couldn't call them genes. He didn't know what DNA was, but he realized there was some kind of inherited piece that would be stronger and mask one, and another inherited piece that might be weaker or be hidden. So, in pea plants, purple flowers are dominant, big F, are dominant to white flowers, little f. I want you to use these Punnett squares to figure out the genotypes of the rest of the family tree. Here's my hint to you. Start with this white flower. You know what its genes are. Work yourself backwards from there. So big F is a purple flower, little f is a white flower. Move myself out of the way here. Please use these Punnett squares. So this would be like the two parents in the first generation making the second generation. This would be the two parents in the second generation making the third generation. Then the second model is here. Strawberry plants, this is from the Do Now, if you remember, can reproduce asexually. They can reproduce asexually by dropping new baby plants into the soil. If you've ever grown strawberries, you know this. Mr. Murphy planted like 3 strawberry plants a few years ago, and now half of my garden, the garden bed that they're in, is covered in strawberry plants, because every year they kind of drop a couple more, boop, 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 and it just grows and grows and grows. So large leaf size, big S, is dominant to smaller leaves, little s. Check out the family tree, check out the genotypes and the traits in each of these plants. In the model, so what you need to do is over here, review the model carefully and then describe in detail any problems you see in the model of strawberry reproduction. A problem with this model is, I know this is incorrect because these are the kind of things I want you to write about. Okay, so in class, we had kids start talking about this. Like first, like for 5 minutes, they went through this, so they didn't finish them. Then I'm going to have you finish your two models during independent work. So I want you to kind of think about it, talk to each other about it, and then finish it. And so I gave you all those hints just now, so I think you're okay. Specifically look down here if you need an extra hint. And then you have this reflection slide. And then you're going to copy and paste them into your science class portfolio. So here's your reflection slide. What this type of model shows is capital letters represent, lowercase letters represent. I am proud of this work because when this unit started, I thought, but then I learned that. These are all things I want you to think about. How much did you learn? If you looked back at this in 6 months, in a year, if you went to 8th grade next year and your 8th grade teacher asked you to look back at your science class portfolio, I want you to write enough here that you remember what it was like doing this model. And hopefully you'd be like, oh my gosh, I was so young then. I didn't know what I was doing, but I'm so much smarter now. I've learned so much. We want you to keep building on your understanding as you get older and older and older. So take your time, fill this out, take a few minutes to fill this out, and then you're going to work on your portfolio. So if you were in my class, you've already started this. So you can go back to the resources tab in Google Classroom and open the assignment, and it should already have your name on it. There should be some atoms that you created, or some molecules that you've modeled with different atoms already in there. If this is the first time you've done it, then there'll be like 4 slides when you come in, and that's okay. Make sure your name is on the front. So this is the same thing. Open your portfolio. Then you're going to copy and paste these 2 slides from today's slideshow. After they're done, get them done first, then copy them, paste them into the other slide. So you're going to go back and forth between the 2 tabs. Always make sure you click on Keep Original Styles, or they won't look the same. They'll be like a weird background, and it'll be hard to read them. Then, after you finish the reflection slide, copy and paste the reflection slide into your portfolio. So you're copy and pasting 3 slides, 2 models, and one reflection. And now, if that would be it for you, if you took your final assessment yesterday. If you did not, click on here and take that final assessment that you missed in class yesterday, please. That's it. No school tomorrow. Get some sleep. Please don't stress too much about the election. It's going to be okay. We're going to get through this together. We appreciate you here at Chinook. We love you. We're going to keep you safe no matter what. Have a good day. We'll see you on Thursday.